Hello everyone, thank you so much for joining me today. We're going to get started here in just a moment. All right, it's 4 o'clock. Again, thank you all so much for joining me today as we explore the new Inference application on the NumWorks graphing calculator. My name is Nick Koberstein. I'm a math teacher in residence at NumWorks, and I'm very excited to dig into this new and updated application and answer any questions that you might have. The chat is open during the webinar. Feel free to, if you are on a computer, drop in some questions into the chat. You can introduce yourself, let me know where you're from. I'll be taking a look at that chat as we go through today's webinar, and I'll try to answer any questions that come in, as I see them. So again, feel free to drop anything into the chat. Let me know who you are, where you're from, how you heard about us. I'm excited to, again, dig into this new Inference application with you. Maybe you can also just let me know if you can hear me all right. If there's any technical issues, feel free to drop those in. There'll be a little bit of a lag, but I should be able to pick those up. All right, so like I mentioned, we have a new and updated Inference application. This came out with version 17. The probability application, which used to be on the screen, has now been replaced with the Inference application. It's going to add the ability to do statistical tests, so your significance test, and also to calculate confidence intervals. If you've not had a chance to update your calculator, you could follow along with me on our online simulator. That's what I'm using today. Or you can update your device very simply. You don't need to download any external hardware or software. You're just going to go to my.numworks.com. I'm going to drop that into the chat here, my.numworks.com. You should have an account on there, and you just plug in your calculator. It'll be about a 35-second process. All right, so what I'd like to do now is just go ahead and open up that Inference application. We can see it up right here. We're going to open that up and take a look at what we're going to do. So I'm going to switch over to my screen so that I've got my Inference app here right behind me, and I'm just using my online simulator today to take a look at some examples. So when we open up the Inference application, I'm going to navigate over and down to Inference and click OK. When we open up that Inference application, you'll see it actually contains three sub-applications here, three programs that we can use. One is that traditional probability app, the one that we had access to before, and our two new programs, the test, that's going to be your significance test, and intervals is going to give you access to confidence intervals. What I want to do before we dig into test and intervals is just do a quick demonstration of the probability app. This might be your first time taking a look at probability and how this works on NumWorks. So I want to go through a couple examples of how to use the probability section of the Inference application. So I'm going to click OK on my calculator to open up the probability app, and we see that we have several probability distributions. Now, the focus of today's webinar really is I'm thinking about some AP Stats problems here, so I'm focused on high school statistics. So we have every probability distribution you're going to need for high school statistics, and even more than that. So some of these distributions you might not be using in your high school courses, but they do have access. This is going to get you all the way through some of those college courses as well. We've got our normal distribution, chi-squared distribution, and the student's t-distribution. So if you're looking for the t-distribution, that formal name is student's t-distribution. Whenever we open a distribution, if I click OK, for example, on the normal distribution, we're going to have to choose some parameters. So for the normal distribution, we're looking for the mean and the standard deviation. I'll go ahead and do an example where my mean is 128 and my standard deviation is 12. Now that I have those parameters entered, I can click Next, and we're going to see both this probability statement as well as a graphic representation here of our normal curve. At the very top here right now, it says probability that x is less than or equal to, and it says 0. This is where we can insert a value. I'm going to use my keypad here I could do the probability that x is less than or equal to, let's say, 120. When I click enter or OK, I see that that's gone in, and I can see my probability of 0.2525, and in my graph I have that area shaded below that corresponding area. So here's a cumulative density function. We're doing less than, but we can also switch that. Over here, this button is a button. It's a drop-down box. So I'm going to use my left arrow key and click OK, and we can actually find the area between two values or the area to the right of a value. So if I wanted to find the area between two values, I'll click OK, and now I can change that lower bound, maybe 110, and the upper bound, we'll say 145, and we're going to get that area between those two numbers. So similarly, if we wanted to do an area above a value, we'd select that third option. Now we can also do our inverse operations all within this same application. I don't need separate functions for that. So for example, when I'm in this middle option where I'm finding the area between two curves, I can actually navigate to the right and enter a probability. So instead of entering the x values, I can enter the probability. This is going to find the middle blank percent. So if I'm looking for the middle 95%, I can put 0.95, and that's going to give me those x values for which between them we'll find 95% of the data. We can also work, if we don't want to do between two values, we could come drop down, pick the maybe less than, and if I'm looking for the 90th percentile, I'm looking for 90% to be to the left of me. So again, I can do those inverse operations all within that same app. So again, that's your probability app section of the Inference application. Just some examples of when the mean was 128, standard deviation 112. We can type in some x values, or we can type in the probability. So we can work directly or inversely with this function here. Again, if you have any questions or if there's specific examples you want to see, feel free to drop those in the chat. You're welcome to just follow along. If you want to try this on your own calculator, let me know if I'm going too quickly or if there's something you want to see again. This is going to be this is recorded, so you can always come back and watch this again on YouTube later if you missed something or you want to try something again. I'm going to click this back button. For those of you just joining us, what we're looking at is this Inference application. This is the new application that came out in January of this year with version 17. It hosts 3 sections. It's got your probability section, your test, and your intervals. And we were just taking a look at the probability distributions. I had a normal distribution there. What I'd like to do now, let me go back to my notes for 1 second, is take a look at the other sections that are in here, the newer sections, which are going to be your test and your confidence intervals. One thing I want to mention, just in case you joined us and you missed this before, in probability distributions, one question that we sometimes get asked is about the t-distribution, and that is available. It's going to be listed under student. The formal name is the student's t-distribution. So if we open up that distribution, we can enter our degrees of freedom, and then we can do the same thing we did with our normal distribution, but with our t-distribution. So I can find the area to the left, the area between two values, or the area to the right. If I'm looking for that t-star value for like a confidence interval, and I want to find a 95% confidence interval, I know 5% is on the outside, 2.5 on each side, so 0.025 is going to give me that t-star value that I can use to manually construct a confidence interval. All right, so speaking of confidence intervals and tests, let's back out of my t-distribution. Let's back out of the probability section. Let's go ahead and take a look at our test and interval new section. So these are brand new with version 17, really helpful for those AP Stats classes. In fact, what I want to do to demonstrate these features is I'm going to look at some released free response questions from some former AP Statistics exams to guide our exploration. So I'm going to switch back to some notes here so we can take a look at a problem. So let's take a look at this question. This question is from 2018. It's question 4, and it says that the ACL is one of the ligaments that helps stabilize the knee. Surgery is often recommended if the ACL is completely torn and recovery time from the surgery can be lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time for the surgery. To test the effectiveness of the new procedure, a study was conducted in which 210 patients needing surgery to repair a torn ACL were randomly assigned to receive either the standard procedure or the new procedure. So question A says, based on the design of the study, would a statistically significant result allow the medical center to conclude that this new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? Explain your answer. Now, our calculator is not going to answer this question for you. This is something that your AP stats are going to have to take a look at themselves. But yes, since those patients were randomly assigned to the two procedures, which is going to reduce the chance of the confounding variables having an effect on the results, it would be reasonable to conclude that the new procedure does cause a reduction in recovery time for patients similar to those in the study. Now, question B is where our new application is going to come into play. So question B states that the summary statistics on the recovery time are shown in our table, and it wants to know, do the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure? So we're looking to see if there really was a reduction. So what I'm going to do is I'm going to switch back over to my calculator screen here. And because we're looking to see if we have statistically significant evidence, we're going to do a test. So I'm going to navigate down and open my statistics, my significance tests. And we need to choose which test. Now, one thing I really like about this application is that we are really avoiding those abbreviations that can confuse our students. We don't see things like 1 prop z int in the middle of our list that we're not sure what that means. We're getting that confused with other things. So from our test, we need to select two means. We were given data from two different groups, the standard procedure and the new procedure. And so what we want to do is we're going to navigate down to two means, either a t-test or a z-test. Now, we strongly recommend that t-test because we do not know the standard deviation of our population. So we're going to select a t-test. And then we're asked for the null hypothesis and the alternative hypothesis. Now, our null hypothesis is going to be that there is no difference. That's our assumption to start, is that the two procedures have no change. There is not a reduction. And what we want to see is, does this new group, if we look back at our notes here, they listed new procedure as the second option. So I'm going to let that, I guess that's over here. I'm going to let that be mu2 to represent that. So I'm going to be looking for mu1 minus mu2 being greater than 0. That my second group, my new group, had a smaller recovery time, and so its average is less than my standard. So that larger number minus the smaller number, it's a positive number. Mu1 minus mu2 is greater than 0. So I'm going to keep that. If I wanted to change it, I could, of course, come to this drop down and select my appropriate alternative hypothesis. All right, so now what I'm going to do is I'm going to go to Next and click OK. I'm just watching the chat to see if there are any questions. If you're just joining us, we're taking a look at the new Inference application of the NumWorks graphing calculator. If you have not updated your calculator, just head to numworks.com. You can try it online, numworks.com/simulators, that direct link. We're in the Inference application. We're looking at a 2-sample t-test for means. So I have entered my hypotheses. I'm going to click OK. And now we're asked for our statistics here. So this was given to us in the table. I'll put those back up for just a second. So we're given our sample sizes, our means, and our standard deviations. So we're going to enter those into our calculator. So group 1, sample 1 is that standard procedure. So group 1 is going to have a sample mean. If I look back at my table for a second, that sample mean is 217. The standard deviation was 34 days, and its sample size was 110. And then sample 2 had a mean of 186. That was 186 days for recovery. Standard deviation was 29, and its sample size was 100. So after entering those hypotheses, I can enter my statistics, and we can also enter our significance level. A significance level was not provided in this problem, so we'll just use our standard 5%, 0.05, and I'll navigate down and click Next. And here we have all of our calculated values, so the things that we're going to need to make a conclusion. We have our t-test statistic of 7.12. That's going to give us a p-value of 0, and our degrees of freedom has been calculated as 207.1791. So this is all the information I would need to then make a conclusion. But one thing that is really great about this NumWorks graphing calculator is that we have one final screen that's going to put all that together, give us a great graphical representation and that conclusion. So if I click OK, I can see my t-distribution here. Remember that my t-test statistic was 7.127, so that's off the screen. The area under that curve is basically 0. And since we gave a significance level of 5% and our p-value is just about 0, that is less than our significance level, so the null hypothesis can be rejected because the p-value is less than 0. So that conclusion is given. Of course, AP is going to ask you to state and conclude, so we're going to have to make sure we talk about this in context, which the calculator will not do for you. So we've broken down that barrier of having to memorize those things and getting tricked up on that, but now we can answer those deeper questions about what this means in context. What I'd like to do is compare what we got on the calculator with the scoring guide for this question. So I'm going to switch back to the problem here, and I've pulled up the scoring guide. Again, this is from the 2018 AP Stats exam. This was, I believe, question 4. And the first step was to state the correct pair of hypotheses. It will be very important that your students define their parameters. So our hypothesis match here, we've got that the null hypothesis is that they're the same, that they're equal, that the difference is 0. And the alternative is that we had mu1 minus mu2 is greater than 0. Here they're saying standard is greater than the new one. So again, that's going to be very important for your students to define those parameters. All right, let's get into the math part though. So part 2 actually says to identify the correct test procedure by name or by formula and to check the appropriate conditions. Now, the student's name, or the test name, will be found on the calculator. If we look back at the calculator for a second, up here we do have our 2-sample t-test for means. That's not abbreviated. It's very easy to see that. Again, your students are going to be responsible for checking those conditions. Do make sure that they are remembering what conditions to check for and that they write those out. And then if I look at step 3, correct mechanics, including the value of the test statistic, degrees of freedom, and the p-value. So our test statistic is correct, and we did have that correct p-value and degrees of freedom as well. If we were to look further into the scoring guide, a student would receive essentially correct if their parameters are correctly defined, their hypotheses are correct, the name of the inference is correct, or the formula. They did not have to do both, so we could just write the name, and the correct t-test statistic is calculated. The guide, however, does not require students to show work on this problem. So they did not, as long as they checked all their conditions, hypotheses, defined their parameters, have all their correct values, make a conclusion, they did not have to show the work for this problem. So this is an example where this calculator would really allow you to breeze through those calculations. The device is there, the tool is there to do that work for you so that you can answer those deeper questions. Step 4 then was to state a conclusion in the context of the problem. So again, we have that conclusion on our calculator that says the null can be rejected because the p-value is less than alpha, but that's only part of this problem. You still have to make sure that is in context. So your students will be required to come back to the original problem and think about, what does this mean for the context of this problem? All right, so we're now going to take a look at a question that involves constructing a confidence interval. Before I jump into that, I want to make sure that if there are any questions, you throw those into the chat. Anything about the probability distributions we looked at previously or the significance test, we're going to move over to doing a confidence interval. But I do want to make sure there's a chance to ask a question. There's a little bit of a lag between when I say something and when you hear it. So if you type a question in after I start, I'll be sure to come back to that question as soon as I can. So let's go ahead and take a look at this question. So this question is from 2017, and it says that the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink, tisk tisk, from the beverage fountain instead of filling it with water. Manager has selected a random sample of 80 customers who asked for a water cup when placing an order and found that of those 80, 23 filled their cup with soda, a soft drink from the beverage fountain. We want to construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, would fill the cup with a soft drink from the beverage fountain. All right, so we're looking at a confidence interval here. What I'm going to do is switch back over to my calculator. I'm all the way in a significance test of the Inference app. What I need to do is back out to that main menu of Inference. So I'm going to click this back button just a few times just to get back to my main menu here. And I want to look at an interval because I'm supposed to construct a 95% confidence interval. So I'm going to navigate down and click OK on intervals. And here again, we've got fully written out words. This is great. We've got one proportion Z interval, one mean T or Z interval, and then two proportion 2 mean. Now we're looking at a proportion. We're looking at the number of people who filled up their soda with soda out of those who asked for the water cup. So we're doing a one proportion Z interval. So I'm going to click OK. And now we're asked for the number of successes. This is the number of people who did fill their cup with soda instead of water out of that sample size. So if we look back at that problem, it was 23 individuals out of the 80 from the sample size. And it was a 95% confidence interval. So I'm going to keep that confidence level at 0.95. I'm going to navigate down and click Next. And now we have our calculated values. We have our sample proportion p hat. We have our Z star critical value. We have our standard error. Again, I love that we're getting our notation and our vocabulary word here. Those legends are very helpful. We also have that combined margin of error. So this is everything I would really need right now to construct the confidence interval. But just like with the test, we do have another final screen that's going to summarize all that information. Here's my confidence interval. I can see the endpoints here on this curve. So that's my lower and upper bound of my confidence interval. If I prefer my notation of my point estimate plus or minus the margin of error, that's another way I could write that. So I've been given all that information I need to answer this question. Let's take a look real quick, though, at part B of this problem. Part B says that the manager estimates that, because we would still need to interpret this confidence interval, but we'll get to that in just a moment. The manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. Suppose that in the month of June, 3,000 customers ask for a water cup when placing an order. Use the confidence interval from part A to give an estimate for the cost to the restaurant for the month of June from the customers who ask for a water cup but fill it with a soft drink. So we have to do a little bit of work here. We constructed a confidence interval or interpretation of the proportion of people who ask for a water cup but fill it with soda. But now we need to figure out, that's a proportion. What would that be? What would be the number of the 3,000 customers who do this? And how much would that cost the restaurant if it costs 25 cents per person that does that? All right, so what I'm going to do is I'm going to, before I leave this, I'm going to copy, let's go back to the calculator. Before I leave this screen, I'm going to copy this confidence interval. So right now, if we take a look at our calculator, there are actually some shift options. That's the yellow button here on the left. And if we look at the top, we've got copy and paste. So what I'm going to do is I'm going to shift and I'm going to copy, and that's going to copy the lower and upper bound of this interval. It's going to be like a 1x2 matrix that's going to contain these two values. And what I'm going to do is click my home button, and I'm going to go to my calculation application. And if I shift paste, that's the button under OK, that's going to copy and paste that confidence interval. And what I need to do is say, well, this is a proportion. So what's my count out of my 3,000 customers? I'm going to multiply this interval by 3,000. So now I'm really just doing scalar multiplication of a matrix here, but now I have an interval for the number of people out of 3,000 who are going to ask for a water cup, but fill it with with soda, because I'm 95% confident about this. And again, I'm looking for the cost to the restaurant. We said it's 25 cents per customer that does this. So I'm going to multiply this answer by 0.25 to get an estimated cost of $141.23 to $290.03. All right, so those are my two answers there. Let's take a look at what the scoring guide would say for this problem. All right, so here's my scoring guide. Part A says to identify the appropriate confidence interval by name or formula and to check the appropriate conditions. Once again, your students are going to be responsible for those conditions. But if we take a look back at our calculator and we go back into our Inference application, very top here, one sample, Z interval for a proportion. So our name of our inference method, our confidence interval, has been identified. So we should be able to get credit for that problem, but I still need to make sure that I list and check my conditions. Our step 2 is the correct mechanics. We need to report the sample proportion, p hat, and the confidence interval. There's that confidence interval. Oh, you're not seeing that, I'm so sorry. Step 2 was the correct mechanics. So we needed the sample proportion, p hat, which we can actually see on this final screen, 0.2875. Final screen right here, back and forth, back and forth. And we also have our confidence interval down here at the bottom, which if we look at the scoring guide was also needed. Once again, if we take a look at this scoring guide, we did need to report the correct sample proportion, the Z critical value, the standard error, the margin error, all that's given to us on the calculator. But for this scoring guide, supporting work was once again not required, but if it was provided, it had to be correct. So we're not required to show that work, just giving my p hat and my interval here at the end was all that was needed. But if you do show work, you have to make sure that work is correct. Step 3, of course, is that interpretation. Your students will need to be able to interpret that interval in the context of the problem. So we've provided that interval 0.1883 to 0.3866, but the students have to think about what does that mean in the context of this problem. And then part B, using that confidence interval, we should find that the 95% interval estimate for the number of customers, if we just multiply by 3,000, which is exactly what we did, we got that same interval, 565 to 1,160. Multiplying that by 25 cents gives us that same value, $141.25 to about 290. Now on the scoring guide for this one, this does require supporting work, which is really exactly what we did on our calculation screen. So we would want to make sure that we show that work, multiplying those endpoints by 3,000, multiplying those endpoints by 25 cents. All right, I do have one more example I'd like to take a look at here, and that's going to be using a chi-squared test, a chi-squared distribution. Again, if you have any questions about anything I've gone through, feel free to drop those into the chat. I'll also have this recording for you available on YouTube to watch later, so you can take a look at these questions yourself. So let's review a chi-squared distribution question. So here's number 4 from 2013. It says that the Behavioral Risk Factor Surveillance System is an ongoing health survey system that tracks health conditions and risks behaviors in the U.S. In one of their studies, a random sample of 8,866 adults answered the question, do you consume 5 or more servings of fruits and vegetables per day? The data are summarized by the response and by age group in the frequency table below. Do the data provide convincing statistical evidence that there is an association between age group and whether or not a person consumes 5 or more servings of fruits and vegetables per day for adults in the U.S.? All right, so here we are looking back at a test. So let's switch back to our calculator. I'm going to click the Home button, and I'm going to head back into Inference, our new application, and I'm going to back out to our Inference main menu. Again, if you're just joining us, we're taking a look at the Inference application, and we're taking a look at a chi-squared test. So I'm going to navigate up to Tests, and we see here at the very bottom, we do have our chi-squared test. I'm going to click OK, and we have to choose either a goodness of fit or a test for homogeneity or independence. If we look back at our problem, we were asked if there's evidence to support that there's an association. So we're looking here at our test for independence. So I'll navigate down and click OK on homogeneity and independence. And now I have a table I need to fill in, and I'm just going to match exactly what I was given on the problem. So I've got 2 columns here, yes and no, and 3 rows for those age groups. So in the calculator, we just have generic group 1, group 2, group A, group B. We can see that right now, the second column, second row are grayed out because those are optional. But I'm going to start to enter in values. So 231. I'm going to take advantage of the keyboard from using the simulator to type the rest of these values. So for yes, under the age group 35 to 54, that was 669. Notice that another row has been added for me. Again, it's optional, which is why it's grayed out, but I do need it, 1,291. And then I'm going to navigate up and over to the, this is column no, 18 to 34, that was 741, 2,242, 3,692. Notice that I do have a new column here. Again, that's grayed out, it's optional. I don't need it for this problem. Navigating down, I'm asked for a significance level. One was not provided on this problem, so I'll just use 0.05 as my standard and click next. Here I have my total and my expected values calculated for me. So for each of those cells, I can find those expected values, and then on the ends, I can find the total. It's a great way to also just check my work. If I go back to the problem, I can make sure those totals match. They're looking good. And I need those expected values when I'm checking my conditions. Let's navigate down and click next. Here are our calculated values. I've got my chi-squared statistic. I've also got my p-value, 0.011, and my degrees of freedom. I would need to report all of those values on my test. Click next. We're going to be given that chi-squared distribution for degrees of freedom 2. And once again, since we provided that significance level and the p-value is calculated, here's that conclusion. The null hypothesis can be rejected because that p-value, 0.01, is less than alpha. And I can also see that chi-squared statistic here on that distribution. Let's take a look at how this compares with the scoring guide for this problem. All right, I did just lose my notes. There they are. All right, so it says, there it is. There's my scoring guide. Step 1, state a correct pair of hypotheses. So students will need to state their hypotheses. Now, since these are going to involve context, the calculator is not going to include the hypotheses on these tests. So these will be in terms of that context. The null hypothesis is that fruit and vegetable consumption is independent or is not associated with age group, versus the alternative hypothesis that they're not independent or that they are associated. So that'll be the responsibility of the user to type those hypotheses. Step 2 is to identify the correct test procedure, again, by name or by formula, and to check the appropriate conditions. If we take a look at our calculator, we are told up here that this is a chi-squared test. Now it's either homogeneity or independence. Your students will need to make sure they identify which one this is. The question asked, is there an association? So they should understand its independence. You can also think about how your sample was collected to identify if that's homogeneity or independence. Now, checking the conditions is something I do want to chat about. Again, they'll need to check those conditions, but one thing that is very helpful on this calculator is having those expected values reported while you're working through this, because you will need to, if you look at the scoring guide, make sure that each of these expected values is at least 5. One trick on that is instead of writing all of them down, you can note which expected value is the smallest and that it is greater than 5. which would then imply that all the other ones are greater than 5. So you would have to report at least one of those and identify it as the smallest expected value. But those expected values are provided on the screen for you, which is great. And then if we take a look at step 3, that's the correct mechanics, including the value of the test statistic and the p-value. So if we take a look at, and the degrees of freedom, yep. So if we take a look at our calculator here on that final screen, here's my test statistic, my p-value, and my degrees of freedom. And then step 4 says to state a correct conclusion, again, in the context of the study. So I know that this last problem, our slide on the calculator, is super helpful for students who sometimes get stuck about, you know, do you reject or not reject or accept? Please don't ever say accept. But your students still have to think about, what does this mean in the context of the problem, right? So the p-value of 0.01, I need to make sure I identify that, is less than alpha of 0.05. But what does that mean, right? So we need to make sure that we can talk about being able to reject the null hypothesis because of that comparison. How does that relate to the context of this problem? So you want to make sure you're still emphasizing that. All right, so those are the examples that I wanted to go through. We went through the probability distributions. We did both a direct calculation and an inverse, found the values of x for a given probability. We did some tests. We did some confidence intervals. So at this point, I just want to see if there's any questions that we have about, any questions that we have about the inference application. I also have here a survey. I'd really love your feedback on a couple things. One, the presentation. Are there any questions you have about the inference application? Any feedback you have about the application? Anything I can do to better help support you in using NumWorks and seeing how the inference app can work? Also, if you're an educator and you want some credit for hanging out with me for the last 45-ish minutes, you can fill out that survey and let me know that you're an educator, and we'll just send you a little certificate that says you participated today. But I'm just going to pull up the chat. I lost it under a window, and make sure that there are no more questions. Let me just find that window. Where did you go? Where did you go, chat? It's somewhere. There it is. All right, I don't see any questions so far in the chat. So if there are no questions, I'll hang out for a little bit. But otherwise, thank you so much for joining me. I'm going to just get rid of myself for 1 second so you can see my email address. If you have any questions, feel free to send me an email. That's nick.koberstein@numworks.com. I'd love to answer any questions you have. If we need to hop on a Google Meets and chat about something, you can feel free to send me an email and we'll do that. Or if it's just a quick question, I'll respond via email. But thank you again so much for hanging out with me today. Feel free to drop some questions in the chat and I'll get those answered as they come in. Otherwise, thank you so much.